Now with these tools, you'll just become much more productive if you use them. So people will just be able to do more. If you're writing, for example, an algorithm, and before you tested typically 2 or 3 different approaches because in the end you had a limit of time on how much you could work on the project. Now within the same amount of time you can test 10 or 15 different methods. So I think people will just be much more productive and more will get done. But I don't think it will change the way we write code, but it won't change this task and the need for programmers, in my view.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, How to Live Longer, Healthier Life. We are produced by Inside Tracker, your science-based guide to optimize your body from the inside out. Our guest today is Dr. Eran Segal. Professor Segal is a computational biologist and professor at the Weizmann Institute of Science in Israel, specialized in artificial intelligence, machine learning, and personalized medicine. His research focuses on understanding how genetics, microbiome, and nutrition interact to influence health and disease. He is widely known for his groundbreaking work on personalized nutrition, demonstrating how individuals respond differently to the same food based on their unique biological makeup. By integrating large-scale data analysis with cutting-edge computational models, Professor Segal aimed to revolutionize precision medicine and optimize dietary recommendations for improved health outcome. Over the years, Eran published more than 200 articles in scientific and medical journals, which have been cited over 60,000 times. He earned his BA in computer science and economics from Tel Aviv University and his PhD in computer science from Stanford University. Welcome, Eran.
Thank you, Gil. Thanks for having me.
One question that I have, and I never had the chance to ask you, is about a postdoctoral fellowship. Have you done it, or you jumped immediately to be a professor?
I did a short independent postdoc position at Rockefeller University in New York for a little over a year, and then I joined the Weizmann Institute.
Cool. So that's pretty unusual. Usually a scientist spend much longer. So again, showing how successful you are. So thank you again, Eran, for joining us. And just a couple of warm-up questions before we'll move to our main dish, as I call it, discussion about AI, machine learning, LLM, and so on, is just a bit of more background about you. We had an interview with Eran a few years ago, if anyone wants to refresh his memory, and we discussed the personalized nutrition and the really groundbreaking work that Eran and his team have done a few years ago. But today we'll try to focus more on machine learning and so on. But just to refresh our audience memory, first question is, what inspired you to become a scientist?
I think the curiosity and solving riddles and I guess I drew inspiration from my father, who's an organic chemist. Actually, he told me this sentence that stuck in my mind, which is he said that the more he studies and the more he learns, the more he understands how little he actually knows and understands. So I think I've always been, very intrigued by everything around us and trying to figure out how things work. And I think that's what, in the end, drew me into exploring these questions and, becoming a scientist.
Yeah, that's a great sentence. With your permission, I might steal it sometimes. It's a great sentence.
Please.
So now let's say just very quick about personal health and nutrition. What are personal health and nutrition?
I guess it's the field of trying to optimize one's health given the personal parameters of a person. That's how I would put it very broadly. And of course, this personalization can actually happen on many, many different scales. So at the very top, you actually have no personalization, and then you give kind of a one size fits all recommendations, nutrition and lifestyle. Then you can go down to, let's say, very, very broad clusters of individuals, which may depend on either just the personal habits. The vegetarian people will not eat meat, and so on. And then you might tailor it to the genetics, but very very broad, not even to the individual, but to the let's say to some specific type of population. And then you might tailor it to the geography and so on and so forth until you can actually reach a level of personalization that really looks at specific parameters within a person. And I think actually working on all of those scales makes sense. There are definitely recommendations that are broad in general, and we should also include them. That would be even one size fits all. You know, don't eat junk food and do more exercise is probably a good advice for everybody. But then if you want to the exact type of exercise and the duration and intensity and so on, those definitely would be tailored to at least the age of the individual, and then many different parameters about the current fitness level of a person and abilities and so on and so forth. And so the same goes also with nutrition. So I think the whole field is tasked with just basically improving one's health more and more with growing levels of details of how you tailor it to the individual.
Yeah, thank you so much for this explanation. Was pretty simple. I couldn't explain it in a so simple way. So thank you so much for simplifying it. That's great. And how does, in your opinion, personalized nutrition related to longevity?
So I think it's related in the sense that, of course, first of all, in general, what we eat obviously is very key for our health. If you think about it, that's probably the most important thing that we do. This is what we put in is what our system will have to process in terms of the micronutrients, in terms of the fuel, the energy, the junk that and the waste products that need to be evacuated and so on. So we know that it's very key, and if it's very key for our health, then it definitely is a major determinant of our longevity. But also, I would say both lifespan, but also health span, which is actually the latter one that we really want to focus on and improve.
Absolutely. And speaking about food, let's move to the meat and potato of the discussion and start with just a general introduction for anyone that was sleeping in the last 10 years. So what are artificial intelligence and machine learning?
So machine learning and artificial intelligence are basically computer-guided algorithms that can give us useful data and information across many different domains, but they're generated by a computer and not a human being. I said it purposely very, very broadly because within the field then of AI and machine learning, there are many, many different applications and tasks and many different methodologies. And of course, there's no one method that is the silver bullet for every different task and applications. And so within that machine learning, typically when we talk about that, we're talking about in the past several decades, statistical applications of algorithms to data for some specific task, like putting various samples into clusters or buckets, or being able to predict one's current status or predict things in the future. And by artificial intelligence, we probably mean being able to do tasks that a human being would do, but be able for a computer to do that. And increasingly, we're seeing in the recent years more and more complicated tasks being successfully implemented by AI tools, to the point where at some point, I think in the very near future even, we're going to see even superhuman capabilities for AI in at least some specific tasks. And maybe we're already seeing that today. Not on all tasks, but on some tasks.
Okay. No, thank you so much for that. And a few more terms before we'll get deeper is the next one is, what is deep learning?
So deep learning is now a very specific type of model system. It has to do with a mathematical framework that is called neural networks, where we actually have a graph. The graph represents a computation graph, where every node performs a simple function in computation and receives some input, generates some output, which is then passed on to another computation node that is called a neuron. And eventually, these neurons feed within large systems into eventual final nodes that produce an answer, like, for example, whether a person has or does not have cancer, or can predict the next word in a sentence, and many different tests. But this is a very general architecture, and we use data to learn it, which is where the word learning comes from. And the word deep comes from the fact that in recent years, these models, due to the availability of data and compute power, have become very large. So with many layers of these networks and node layers of computation, so we call them deep networks, and deep learning then is the field that applies these network architectures to data and learn useful models.
And what are generative models, and what is the difference between deep learning and generative models?
So deep learning is actually one method by which we generate generative AI models. There's other methods to generate AI models, but generative AI models, or Gen AI models for Gen AI models for short. And generative AI models have to do with defining some probabilistic distribution, some probabilistic view of the world, by which I can start with something and I can sample and I can generate a sequence of events. These events could be words in a sentence. So everybody's familiar these days with ChatGPT. So you ask it a question, and the way it generates an answer is actually it takes your sentence and your question, and it computes then what would be the next word, which would now be the first word in a sentence that answers your question. And then given that then it uses that word as if that word was actually part of the sentence and what you asked, and then it generates the next word, and then the next word, and the next word. And this generation process is called generative AI. And one can do it also with imaging, with sequence data sequence across time, across space. There are many generative AI types of models, like models that align text and images, for example, like DALL-E, that we're all familiar with, where you go in, you type give me a picture of a man on the moon, and you generate the model generates an image of a man on the moon.
Okay, thank you for that. And follow up for that, what is LLM, and when were they introduced, and what make them unique, and why are they considered a revolution?
LLMs are large language models. They're based on deep learning architectures that we talked about. They're generative AI models. They generate words. They're trained actually by several different methods, but a key component is the ability to predict the next word. The way they're trained is that basically the entire data from ChatGPT, for example, much of the data that's available publicly, and even some not publicly, is being used every time they hide a word, and they ask the model to basically predict that word. And if you can do that for all the words that exist, then the idea is that you probably learned something useful about what a language is, because if you're able on many different types of text and data and different documents to every time succeed in being able to fill out the missing words, then in order to do that, you probably had to learn something useful about what language is. We call them large language models because the models are really large. The estimate is that the models today, some of them have hundreds of billions, some even over a trillion different parameters within this deep learning neural network architecture models.
Okay, and what make them unique? Why are they so exciting, and why you consider it revolution?
What makes them unique is that for the first time, this combination of some mathematical tricks on top of neural networks that existed for several decades, combined with availability of data in the form of all the documents and web pages on the World Wide Web, coupled with then the compute power to actually take all this data, gave the ability to really learn these models at very, very large scale, hence large language models, such that you can really succeed in this task of predicting the next word, and therefore learn a representation of language that is very useful and that was shown to be useful for many applications like chat. These existed before LLMs, but I think the tipping point was this methodology giving us really a leap in the quality of the ability to understand language is what really made them useful, because the models before, there were chatbots for a long time, but they were not giving answers and that were at the quality that comes close to the current models.
So the revolution is basically the amount of data that they can digest. That's what
the combination of data, compute power, some mathematical tricks applied in the right way to this corpus of data. The right way being this learning the next learning next token prediction, learning to predict the next word, which resulted really in models that really capture a lot of the essence of what we consider as language.
Okay. And now there is at least a new Chinese company called DeepSeek that claim that they can do that without the big computational power. So what is your view on that company?
Well, first of all, I would say it's still a lot of computational power. It's they claim to have done it with $5 million use of computational power, which is still a lot. Maybe it's less than the billions that presumably took OpenAI, but it's still I would still consider it a large computation, and their models are still large. I think they made some significant advances on the one hand, but on the other hand, of course, they also built their models on top and with some use of the existing models like ChatGPT. So I think you can't call it as if they did something in void and basically recapitulated everything that OpenAI did with 1/1000th of the cost. So that would not be true. Still, they made some advances in terms of the ability to compact the models for specific tasks. There were also some very interesting computational methodologies and tricks to optimize these models. So I think it was a very nice advance, but for sure, it was also made possible because of the existence of the current LLMs.
Yeah, no, it's definitely an interesting domain. I think that it's just was introduced that the ChatGPT like maybe a couple of years ago, maybe a bit more. And I think about it, how many times a day I'm using it. I would say that it's at least 50. I don't know how many times you use it, but it's so speaking on which, what are some practical use cases you are utilizing them for? And let's assume that our listener, what are the good use cases that our listener can use this amazing technology?
I think it's useful for many different things, and probably we don't have enough time to cover all the different uses and applications that people are using it for. But I would say the way I think about it is that, and of course they're still not perfect, but they have read the whole body of knowledge that is available on every single subject. So if you now want to get access to that data, then your options today are, of course, go and search in Google using keywords, but then I would consider ChatGPT as a much more useful way of doing that, because you don't get in the end a pointer to go and read yourself on the most relevant website, which Google is doing an amazing job at, but you actually are getting back a summary of all the information, and you can really ask a question and get back the information, and that really has many different uses. So I now use it very frequently to optimize any text that I write. So I would write a draft and go to ChatGPT and improve it, whether it's for writing important emails or recommendation letters or grants or papers, and even for reading very long documents that you don't have time to go into all the details. It can do a very good job at summarizing key points. If you want to learn about any subject, you can actually even have a conversation with it. You can many times I use it for brainstorming. So we know that sometimes you can think of ideas yourself, but if you go and talk to a person, you'll improve those ideas just by the discussion. Even if you just have somebody that listens to you and you say your ideas out loud, which you would not do just by yourself, that can improve the outcome. So sometimes I would just use ChatGPT as a colleague to brainstorm with and ask opinions about, and what do you think about this, and feedback, and that actually generates interesting discussions that allow me to introspect my ideas and improve them. So I would say many different applications. Of course, writing code, many of these technical tasks, it is very good at, because it was also trained on billions of lines of code that are available.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At Inside Tracker, we take a personalized approach to Healthspan optimization that eliminates guesswork from your wellness plan. Inside Tracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the Inside Tracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
So what you said is great in summarizing, bouncing ideas, writing codes. I can say for myself that like in the past, I had, as you said, my English is a second language. So I'm writing my gibberish and then put it in, and it's become like Shakespeare almost. And summarizing, it's amazing. Summarizing and editing, and it's make every normal writer like an amazing writer. I think that in a way, the value of writing is a writer, external editor, or something like that is much lower right now. What do you think about, you said about code, and I agree with you. I see that it can write a pretty good code. What is your assumption about the future? Would we still need so many programmers, or basically the need for programmer will reduce significantly?
Yeah, that's a question that I get asked all the time. And I think my answer is that we will need as many coders. They'll just be much more productive. So it's not that there is a finite amount of code to write in 2025 worldwide. But usually, if you look kind of worldwide, you never get to write and everything that you planned for. So now with these tools, you'll just become much more productive if you use them. So people will just be able to do more. So if you're writing, for example, an algorithm, and before you tested typically 2 or 3 different approaches, because in the end you had a limit of time on how much you could work on the project. Now, within the same amount of time, you can test 10 or 15 different methods. So I think people will just be much more productive and more will get done. But I don't think it will change the way we write code, but it won't change this task and the need for programmers, in my view.
Yeah, and I think that it's similar in a way to the Industrial Revolution. Everyone used to be farmer before, and everyone, I assume, I haven't been there at that time, were worried about, okay, what will we do? Because we don't need so many farmers. But then we found different jobs. So I think that maybe some of the programmer will become more like algorithm developers, or other more exciting and something that is more generative and less routine.
But farming, I think, is also different than coding, because in farming, in the end, there actually is a fixed amount, roughly speaking, of food that you need to generate to produce in order to feed the current population. With code, this is not the case, because of course, if you're more productive, you can just do more, and the world will see probably more startups, more products. More features in more new features in any given product than they used to see before.
So innovation and the revolution and the growth of a new technology will be expedited significantly because of those tools.
Absolutely.
And also the cost, I assume. So I remember in the past, think about before the days of all the computing in the cloud, you had to invest $5 million just to buy the computers. Today you go to AWS.
And I think another analogy I like to give is if you think about your laptop, right? So let's say roughly a laptop is $1,000, and that price didn't change for it's not changing for a long time. It probably won't change. Or your iPhone is also, let's say, $700. That they will not lower the price. They'll just be giving you a better and better product with more abilities and more compute, but the cost will always be the same. So a programmer will be a programmer, but they will be now much more productive. And also, like with writers, the gap between a good programmer and a bad programmer is actually going to shorten. And actually, there won't be really very bad programmers if they use English to define what they want to do and then use ChatGPT to get the code for what they want to write.
But I still think that the good or the amazing programmer are the one that coming with something new, and then the ChatGPT won't help you so much, correct? If you write a new kind of algorithm, nothing is the outside. So that's I think still human, at least for now.
I completely agree. Still, even these amazing programmers, they would still they would have the idea, but then the technicalities of, okay, let's write this piece of code in an optimized way. They will probably rely on ChatGPT to get that to get the building blocks.
So 90 to 95% of your time will use that, but then something that is really new, that won't help you, and you need to activate your brain in a way and do that. A great discussion about that. Another cool innovation that's coming, and I think that we are talking about it a bit less, but in my opinion is not less exciting, is the term agents. Can you describe what are agents and what... Let's start with the general use of agent, and later on, let's get to something more exciting like health and wellness.
Yeah. So in general, an agent now would be these AI algorithms, but then I ask them to do a specific task for me. Like, for example, not just use Google to find the cheapest flight, and then I click myself to buy the ticket, but I'll tell the agent, okay, just go ahead. And I want to go from New York to Chicago with on this time window, and this is how much I'm willing to spend, and you'll get back, here's your plane ticket, and it charged your credit card. This is an example of one task that an agent would do. And so by that, you can imagine many different tasks that agents would do. And underneath, they would use AI as a building block components.
Yeah. And what are the potential implication in the health and wellness industries?
So you can imagine here also many different things, like schedule an appointment for me with the doctor, or even go and get eventually, when it's also connected to the physical world, then just get my medications for me. And basically any task that's related to health, you might be able to use agents for.
Yeah, yeah, yeah. I was thinking, for example, in my gym, you need to reserve the class 7 days and 22 hours before. So today, everyone leaving like alarm clock because some classes are really popular. But now you can ask the agent, do it. I want to go to this class every Wednesday at 6 p.m. and you have it reserved and put it on your calendar and add it to your calendar. Or you have a recommendation, or you need to eat this and this food, let's say part of your discoveries because of CGM or...
Yeah, I mean, there was actually this vision, even I remember in the Media Lab in MIT, even in the 90s. But now we actually have, I think back then we did not have, but now we have the tools to actually begin to think of implementing this. But you can imagine kind of a smart room, right? So in your house, you would have sensors connected to your refrigerator, and they would know what's actually there, and your system would also know what type of food you're eating, what diet you're following. It might even recommend, we talked about personalized nutrition before, it might even recommend what's the diet that's good for you for next week, given everything that it knows and measured about you this week. And then it will actually place the order of the missing items that you need to buy. That order would arrive. It would make sure your refrigerator has everything, and even give you the dietary recommendations that you need to follow. I think these types of systems combined with agents are something that we can begin to dare think about would possibly exist in the coming years.
Yeah, no, I completely agree with you. I have a smart refrigerator. So my refrigerator broke a few years ago, and I bought the Samsung smart refrigerator. And I was so excited. At the end of the day, what we have on it is that you have a screen. So we have some picture of our family. And the technology, at least a few years ago, wasn't there. But I agree with you with the agent. If you have and it can be a normal room with a smart refrigerator. You look at the refrigerator, and then based on your blood biomarker and microbiome and CGM and whatever you want to add,
Exactly.
you receive a list of items that you should eat, and then connection to Amazon Fresh or Instacart, and it come to your doorstep. And also maybe not buying stuff that is not good for you. So even if Gil is, I really like chocolate, so maybe chocolate is not good for me. Maybe it will automatically remove the chocolate. And we are lazy. I won't go to the supermarket to buy chocolate, even if I really want it. But if I have it at home, I will eat it. So I think that there are a lot of cool implication about it. That's for me, it's a huge revolution for health and wellness. And in a way, that's what separates us from I don't know, from farm animals, because farm animal is very hard. It's very easy. It's not very easy, but it's easier to come with the plan. It's much harder to implement it. But when you have help with the implementation and you have enough willpower, that will make the plan much easier.
Absolutely.
Yeah. So I'm really looking forward to see the innovation with the agents. And let's go back to LLM and ChatGPT and all of that. In your opinion, what is the best? You mentioned a few, but what is the best if someone need to decide what is the best use of this technology? What would you say?
I think right now it's probably still summarization. So summarization either of existing knowledge that the LLM knows about, or a document that you want to summarize, either yours or somebody else's, or it's probably very good at giving kind of summarization, concise texts for a very, very big body of knowledge. And
I agree. And I can provide an example. We're writing a proposal for some partnership, and we needed for the executive team that are not scientists to write a summary. So we wrote, one of my team wrote, let's write it, summarize it in a level of 8th grader. and then you receive like executive summary in 2 seconds and write it. Think about how hard was it to write it, I don't know, 2 years ago. It might take you a day. Now it's like in 2 seconds. Or when I'm writing a social post, in the past, I was thinking about now write a LinkedIn post based on that, and then make all the emojis and all the hashtag. And it's amazing. It's crazy what it's doing. It's like unbelievable.
Yeah. I think a funny anecdote is if you think of, let's say, you have a CEO of a company now wants to, write something for the company. So they would write something short, like the key message to ChatGPT and say, can you produce a very well-written email about what I just said? But the essence is really something small. So it'll generate a long email that with all the niceties and so on, and you send that, and then people receiving it would say, I got this now long email from the CEO, but what does it say? So you put it into ChatGPT and you say, can you give me back the concise summary? So in the end, you pass through very long text and you shrunk it back, and you could have just sent the key message. So.
Yeah, no, I agree. And I think that it's a great revolution. And Eran, we discussed it a few times offline. There are some limitations for this technology. So I would like you to, if possible, to name them and explain to our audience what are the risks and what are the limitations and what they need to pay attention to.
Yeah, so the key limitation is still reliability. Okay, so there are still we are very still far. The models are improving, but we're still far from solving the hallucination problem. It's called, which means that sometimes the LLM or the ChatGPT will tell you, will give you some truth that it says this is. Will give you some statement and will give you a reference that does not even exist. So this is called hallucination, and so you would still have to fact check and check everything that the model is giving you. If you think about it, now that everybody's using ChatGPT, more and more of the text that these models are actually trained on are becoming texts that are actually generated by these models. So they also contain errors. So sometimes they would learn from bodies of text that themselves have hallucinations within them. So I think this is an underappreciated limitation that will become more and more of an issue, because then you'll even go and you'll search, you'll try to fact check the answer that you got, but you'll actually get back some information out there that would even be from credible sources that also has issues and errors in it, because it also was generated by AI. So then you'll have to really understand what you're looking for and really get down to the source, and that I think that will become more and more of a problem.
Yeah, no, it's a good point. I haven't thought about the massive amount of new data that they create. Isn't it possible to somehow filter it out and basically say, don't use in the model data that come from
but that's actually a research question in itself. How do you distinguish real text from text that was generated by AI? That's also not that easy.
No, I agree. But for me, based on what you said about the limitation, everything that the AI provide to me, I review and I make an adjustment, because as you said, the hallucination is a problem. I'm trying to be very careful, and hopefully everyone should be careful. Don't take it as what you receive. Review it.
Yeah. Exactly. So I think the key limitation is reliability.
Yeah. And just a follow-up question. You mentioned ChatGPT. In your opinion, ChatGPT is the best LLM application, or in your opinion, there are others that are better than ChatGPT?
Overall, probably kind of everything being considered, I think ChatGPT probably is right now the best tool that's out there. But there's the other tools like Grok and Cloud and Gemini are also at very high quality, and it could very well be, and I myself have been playing with it, and I hear from others that for specific tasks, one tool may be better than others.
Okay, that's good to know. And again, we won't drill down into that because that's very specific, but it's good for the audience to know that
Yeah.
all of them are good, but some might be better
Yeah.
in a different application. So if we are trying to move into healthcare and health, what are the best application of generative AI there? And also, what are the limitations?
So I think still it's in the areas that these models are working best, which is on imaging data and let's say voice recognition, natural language processing. So for example, now these models are becoming very good at looking at medical images and providing diagnoses. I think they're very good at that. Um, the also kind of diagnosing, at least I would not rely on this and give medications based on it, but providing the medical background and information of a patient and assessing their condition. These models are becoming quite good with that. I think Google has some of the best models with MedPalm and models that are becoming good and even better than your average medical doctor expert. So still going back to the limitation we talked about before, I would not just rely on them blindly, but these models are becoming very good at working off of this type of data.
Yeah, and maybe one follow-up a point or a question. There are the foundation model that we discuss it, basically looking at everything
Yeah.
and digesting all the internet, and they need the NVIDIA chip that costs, I don't know, millions or billions of dollars. And then there are models on top of the foundation model. Maybe let's discuss it for a second and explain
Yeah.
to the
So the foundation model is really, as its name suggests, is really a fundamental foundational model for a domain, like what we talked about with language, the ability to learn from all the text in that exists in the world and predict the next word gives you some good representation of a language. That still by itself is not the application. So what you then do is you do a process that sometimes it's called adaptation, sometimes it's called fine tuning. And you basically take these models and you fine tune them to work on a specific task. So now you freeze your foundation model. You say, I trained it. Sometimes it's called also like pre-training and pre-training because you're not training on the specific task at hand, which could be, let's say, predict whether or not somebody has cancer. But you would train a foundation model on kind of all the medical history and medical data and blood tests of people. But then you would now fine tune it for a specific task where you freeze the weight of the deep learning model of the foundation model, and you kind of adapt and fine tune it to predicting cancer, for example.
And what is the value of specific data sets? And also in the healthcare domain, there is not as much information outside than, let's say, in the pop culture. So what is
Yes.
Yeah.
You bring up actually an excellent point because the revolution in AI, as we talked about before, was enabled by, it stands on three different legs. One is the data, the compute power, and the methodologies. So if you go to the healthcare domain, okay, we have the methodologies, we have the compute power, but we're actually lacking the data because the data is lacking on two different levels. One is data in the healthcare domain is not publicly available. So there can't be a OpenAI-like company that would train on all medical data available because no company actually has access to that data. And the second is actually, do we have the right type of data? So most of the data right now sits in electronic health records. Those are very good on the one hand because they encompass millions, sometimes even tens of millions of individuals in an HMO. But on the other hand, it's very homogeneous, very shallow type of data because typically it will include just the diagnosis of people, what medication they took, but and some blood test measurements that they did. But there's no real very deep molecular data such as the genetics of a person or the what we call multi-omics, so measurements of, say, your RNA or DNA or protein or metabolite levels. That's on the one hand. And then the other missing type of data is lifestyle and behavioral data, which we know is very key. We just talked about what people eat. That is actually not part of, it should be, but it's not part of current medical data sets. So I would say that much like the text data that's publicly available was the key to unlock these LLM models with the compute power and the mathematical tricks, the health data, whoever holds that data, and especially the right type of data, will be able to unlock. That will be the key to being able to develop these more useful models of AI to the healthcare domain.
Yeah. And you started an initiative called the 10K Initiative, which actually I think that it's a revolution that try to maybe answer those points, the drawback that you described before. So maybe describe the 10K Initiative, what do you have there, and also what is the value of that data?
Yeah, so we started that 6 years ago, exactly because we had the vision back then that it was even predating the current AI models, but we had the vision that you really need to generate a very deep, if you will, deep in a different sense, deep in the sense of now very broad data on an individual to really measure the individual for many different aspects in order to build something like holistic models and useful models about an individual. So that's the goal of this project, is to measure eventually also a very large number of people, but we are focusing on really obtaining many different data types, many different data modalities about an individual. So we capture the previous history by electronical, the electronical health record of a person. So we know all the past blood tests, diagnoses, medications people are taking. But then they also fill out hundreds of questionnaires that are not part of EHRs about their family history of disease, their lifestyle behaviors, nutritional behaviors. They come on site. We do many clinical and physiological measures. We do many imaging measurements like DEXA for full body scans, high resolution images of the retina, ultrasound to look at fat in the liver. We do the whole set of multi-omics. We look at the genetics of a person, the microbiome, metabolites, RNA levels, protein levels, immune system profiling. We use sensors like continuous glucose monitors and tracking devices of physical activity and steps. So it's a very, very broad and deep profiling of an individual. We've done that on 13,000 people in Israel. We just started a clinic doing the same in Japan, and next month we'll start one in Abu Dhabi. So it'll be also an international cohort that will allow us to tap into cultural, ethnic, genetic diversity. And it's longitudinal. That's also very key. So every 2 years, people come back to the clinic and repeat all the measurements. We already have 6,000 people that repeated this a second time after 2 years, and another 2,000 that did this a third time after 4 years, and we're now beginning the 6-year profiling. So as this cohort ages, we're going to get more and more longitudinal data, and I really think this could be a basis for learning the AI models that we talked about in the healthcare domain.
Yeah, and it's getting back to longevity. As you said, you'll continue to sample them for life, so you can start to understand in the molecular level what really happened in our body when we age. And in a big cohort, because as you said, 13,000 in Israel, and I assume that it will be similar size in Abu Dhabi in Japan?
Yes, we hope so, yes.
Yeah, and I assume that it will be in other countries. So I think that's a great resource for aging research, which is very exciting for me, and I assume for our audience, because they are listening to this podcast. So how can you use this data for a model on top of foundation model, and what will be the use case for that?
So we already developed one model, just taking the continuous glucose monitors, because there we actually have the largest data set worldwide of 13,000 people with CGMs. And we did, like you predict the next word, we tried to predict the next glucose value of a person. And because we had, say, 13,000 people, it's 1,000 measurements for a 2-week sensor of CGM. You actually have 13 million data points to learn from. And much like with language, this turns out to be enough to really learn a representation that if you're able to predict the next glucose value of a person 15 minutes from now, we showed you actually learn a very useful representation of the glucose metabolism of a person that is doing a very good job at predicting future onset of diabetes, even all-cause mortality 10 years into the future. So I think that's one application. And we're working now on taking a more holistic approach by integrating several different data modalities. Basically, we take all the measurements that we have about a person, we put it on a timeline, and we try to predict the next medical event, which could be the value of the next blood test you're doing, or the next diagnosis you'll be diagnosed with, or any future medical event. And the idea is that if this is successful, it can really act as your digital twin, because then you can really also simulate actions like taking a medication or changing exercise or changing nutrition, and assessing the impact that would have, let's say, on development of some disease in the future.
And do you see a possibility that the majority of our audience are in the US? Is it possible to simulate me on top of your 13,000 people and come say, Gil, you are closer, let's say, to Eran, and Eran is like that, so most likely that's
Yes.
also a use case, correct?
Absolutely, yes.
So you don't need what I'm trying to communicate. You don't need.
I don't think we will need. I don't think we will
enjoy the value of the 10K.
No. And the more yeah. So even if you have a subset of these measurements for a person, that would help in aligning within the model, and then still making useful predictions for a person.
Yeah, it's very exciting, and the term digital twin is it's coined more and more, and I think that it's we are getting closer to that, and it's going to be a very exciting. And similarly to the 10K initiative at InstaTracker, we have also high amount of data, and I think that that's in my opinion what is missing in the healthcare domain or the LLM domain. Enough data sets that basically you can use in order to develop a new drug or a new product for a food or a new supplement or whatever you are trying. That's basically, in my opinion, is the future. And the data, and I'm hearing it a lot, the data starting to be more expensive or more valuable even than let's say a product. So the data that you create is because of all of this revolution, and because
because we're not there yet, but it will be soon a commodity to basically take data and develop some algorithm or predictor or product. But you need the data in order to do that, and that is, as we know, time consuming and logistically and money-wise costly to collect.
Yeah, no, that's great. Thank you so much for providing this valuable information for our audience and what the future can bring. So in your opinion, what are the best application of LLM in personalized health and nutrition today? What if I'm a user and listener, what can I do with that related to my health today?
So there, I think it's still kind of more the general advice, because I don't think, we talked about where the qualities of LLMs are in summarization, in reasoning and making some reasonings. It's coming to a stage where it's doing it better, but it can't really invent things that are not within the data that it has. So if we did not do trials or did not feed it data of what people ate and what were the health outcomes of that, because that data, does not really exist, not in the public domain. I think we have some of that. You have some of that in InsideTracker, but it's not part of the public domain. So LLMs did not train on that data. They would not be able to give you personalized dietary advice. I think it still can give you general advice just on which foods are good to avoid and which are good to eat in general, but not something tailored for you personally because it still didn't have that data to train on.
Yeah. And I think that we are, in a way, going back to, I don't know, 40 minutes ago when you describe personalization,
Exactly.
starting with
Exactly.
a cookie cutter and getting to based on your CGM and your microbiome, you should eat
Exactly.
apple and or not banana. So the LLM allow you to be in a very high resolution. If you want to, so low resolution, if you want to be in a very high resolution, you still need to use a personalized nutrition or health platform such as
Yeah.
Instant Tracker in order to receive the personalized recommendation. I agree with you 100% about that. And what about health span and longevity? Anything that a user can do today or it's similar?
I think it's still similar. You can get the general advice. This general advice is still very useful, right? If you're not following that, but beyond that, I think these models have not seen the data that would allow them to make these inferences on a personalized level.
Yeah, no, I agree with you 100%. So let's now try to look into the future. And let's say that we are 10 years from now, 2035. What significant changes do you foresee in generally, but also in health, wellness, longevity? How would we behave differently?
Well, I think we talked about some of that before. Like we'll probably see more and more agents. So not just us using the AI to ask questions, but also to perform some tasks for us. That'll probably happen kind of generally. Um, I think we will see, we talked about this too, productivity increase across many different areas. I think there would still be employment for everybody, or at least for, but it's like with the Industrial Revolution, the type of employment will change. People will just do more. In the healthcare space, I think we'll see, I think that will be a slower process again because we can't bypass the need to tediously go and collect the data, which is a lengthy process. But I think still we'll see more and more of these tools applied to existing data sets and useful tools being developed to the stage that I don't know if 10 years from now we'll have a full-blown digital twin that will be super reliable, but I think we will start to get there. And be able to have some form of digital twin of one's self to inquire about potential possible actions and get accurate diagnosis of your current health status.
Okay, that's exciting future. And I always like to summarize the discussion with a top tip from our guest for health span and longevity. So what would you recommend based on the data that you know today? What should they do or not do?
Well, I mean, I think that's if I want to give the real honest answer would be the simple things that if you're not doing the simple things, that's the immediate thing you should do, which is obviously sleep well, stress less, eat well, and exercise. So, I mean, yeah, and of course, anybody would tailor that to one's personal preferences, but I think these are still the key. That's kind of the basis, and then once you have that basis, then you can now you can further optimize and improve. But that would be the basis, and yeah, I think the solid advice you can give everybody.
Yeah, and I agree with you 100%. And I call it the 80-20 rule. 80% is exactly what you said. The 20% is know whether a banana or apple is better for you. It's good. It's for the crazy people like you and me that really want to live longer and better. For the majority of the population, it's okay for them just to follow those points that you said. And
Yeah.
there will
And
be much. Sorry.
I'm confident that if people follow that, we would have seen much less of the cardiometabolic and other pandemics that are really really making many billions of people suffer from their health condition, and of course a big burden on our healthcare system as well.
Yeah, I interview for the last episode Dr. Michael Ringel, which is an expert. He's coming from BCG. Now he's moved to an exciting reprogramming company. And basically he said that if you combine all of that together, including no smoking and drinking less alcohol and all of that, and you look at one group versus the other group, they're doing everything okay in the right way, the difference can be up to 24 years. So just do those a simple task, and you already, most likely on average, again, you can be unlucky and your genetic is very bad, but on average, you can live 84 more years than someone that doing nothing. So it's a lot, and let's start with that.
Absolutely.
So thank you so much, Eran, and we are coming up on our time. We look forward to exploring the research in the field of longevity each month with you and the leading scientists. For more information, please go to www.insighttracker.com/podcast. Thank you so much, Eran. That was a great discussion.
Thank you, Gil. Thanks for having me.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Insight Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.